Alright, so step one, place the horn onto the paper. And I just have 4 pieces of paper taped together to make this big piece of paper. So what I'm going to do is I'm going to outline the circumference of the bell on the pieces of paper so that we can have a circle to measure. So now we have the outline of my horn bell. We can do a few things with this. So first of all, let me get a ruler. Okay, sorry about that. It's apparently surprisingly difficult to find a ruler in my house, but I got 2 now. So our next step is we find something that looks like the diameter, and we take it, and I'm going to have to move our ruler a little bit because it's a bit longer than the ruler. So we have that. We make an angle, and boom. Then connect this back. And voila, we have a right triangle. Now, to find the circumference, we need, well, to find the center of the circle, we need to do that again. And the points where these lines cross, these 2 triangles, should form the center of the circle, right there. Okay, so once we have the center of the circle, which is right there, we can find the radius of the circle. So I'm just going to measure this because it's a straight line from centimeters, and I'm measuring it because it's impossible to find distance just from unlabeled diagrams. So it looks like it is 17.9 centimeters. So radius equals 17.9 centimeters. Now, once we have the radius, we can do a lot of things with that. So we can find the surface area of the circle by putting the radius into the equation pi r squared. So pi times 17.9 squared equals the surface area of that in centimeters. Now I'm going to work this out in the calculator real quick. So roughly 1,006.5977 centimeters, or 320.41 pi. And I'm just going to leave it in terms of pi because that's easier and more accurate. So the surface area of this circle equals 320.41 pi. Now I have to add real quick that the surface area of the bell is different from the surface area of that circle that we have right here, because the bell curves inwards, so it's actually larger than the actual circle. Now that we have the radius, we can also find the circumference of the circle. Now the equation for that is simply 2 pi r. So 2 times pi times the radius. So let's do 35.8 pi centimeters. So circumference equals 35.8 pi centimeters. Okay, so now we're going to try doing something a little bit more advanced, and I apologize for the change in camera angles and the change in microphone quality. I had to switch cameras because the battery in my good camera died. So, we're going to try and find the volume of this curved cylinder, which is just the tuning slide off the back of my horn. So, to do this we're going to need to know a few pieces of data, and I've already actually calculated this out already, just for simplicity's sake and keeping the video as short as possible. So, we need to know the bend angle of this, which this is 180 degrees, and that's just going to be sigma. So, sigma equals 180 degrees. D, which is the bend distance, which is the distance from here on the pipe to here, equals 4.6 centimeters. C, which is the outer diameter, which is the diameter of one of the openings of the pipe, is 1.2 centimeters. W, the pipe wall thickness, and I did have to look this up because I don't have tools to measure something as thin as this, but W, the pipe wall thickness, is 0.05 centimeters. And the bend radius, which it's a theoretical value distance, which I'll flash a diagram up on screen to show what this is. It's difficult to explain with just having the object here. I would need to have a diagram for that. Is 2.3 centimeters. Now, to calculate the volume of it, we need to put it into an equation, well, a formula that looks like this. So, parentheses, pi squared over 4 times c minus w plus r squared minus r plus w squared times c minus 2w times sigma over 360. Now when we actually plug data into that, our data into that, it would be pi squared over 4 times 1.2 minus 0.05 plus 2.3 squared minus 2.3 plus 0.05 squared, which that's actually all one part of the equation right here. I have it circled. Times 1.2 minus 2 times 0.05 times 180 over 360, and I ran out of room on the paper, so I wrote it down here. Now, I did use a couple of placeholder values here to keep the data as exact as possible. I will write out the actual work and rounded forms of this data in my actual work. I'm just using these placeholder values for stowed data on my calculator so I can keep this as exact as possible. So let B be pi squared over 4 times h minus I, which is this part of the equation, the circled part, times 1.1 times 0.5, which the 1.1 comes from the 1.2 minus 2 times 0.05, and the 0.5 comes from the 180 over 360, which is half. And solving all of that out, you will get roughly 8.658 centimeters cubed for the volume of the tuning slide. So, I know I'm just scratching the surface of the geometry of the French horn, but there's a lot more complicated and complex things to do with it that, quite frankly, I don't know how to do. So, I hope this is, just a couple of things that'll provide some insight onto the geometry of this fascinating instrument. Thank you for watching.